2009, Buzz Aldrin writes in his book Magnificent Desolation, "Exploration is wired into our brains. If we can see the horizon, we want to know what's beyond." And he's right. Exploration has been a part of human history for as long as we existed. In fact, we expanded all over the planet, not only in search for more resources or for better land, but also because we're always driven by this deep down desire to know more and to discover more. If you see an island, you want to know what's on it. If you see a river, you want to know where it leads. If you see a mountain, you want to try and climb it. Today, however, things are a bit different, right? I mean, the planet has been entirely explored. We know every single territory, we know every single island, we know how to get there, we know the resources, the language of the people there, the food they eat, and Earth has not only been ground explored, but also space explored. We have thousands of satellites orbiting the planet on a daily basis, giving us information about the weather, the atmosphere, the types of movement of people, the life of mankind in general. But the drive to explore and to discover is still here. The only difference is, instead of having a horizon on our planet, the horizon is now much further and much bigger. And today's video is precisely about that new horizon, space exploration. How did it start? Where did it come from? How did we move from wondering about the meaning of the different stars above our heads to sending armies of probes across the solar system to gather intel for us? Now, humans making theories about the skies above their heads has always been a thing, right? I mean, all around the globe and in ancient times, all different types of mythologies appeared in all civilizations and among very different people with very different belief systems. Ever wondered why she asked you about your astrology sign on the first date? Well, some dude in the past had to try and group stars together and map the skies, grouping them into constellations associated with shapes, animals, deities with a particular belief system, like the Greek constellations or the Chinese constellations, for example. But the first people often credited as being the first early astronomers are the Babylonians, 2000 years BC approximately. They are the first ones to try and identify planets of the solar system: Mercury, Venus, Mars, Jupiter, and Saturn, for example. Now, these planets were correctly identified as orbiting the Sun by Aristarchus in ancient Greece in the 3rd century BC approximately. But despite that, the dominating belief in Europe until the 16th century was the Ptolemaic system. Invented by Ptolemy, it considered the Earth to be at the center of the universe, called a geocentric system, and it also considers that every single object in the sky is actually rotating around Earth itself. But during that same period of time, between the 8th and 15th century approximately, the Golden Islamic Age was happening in another region of the world, and a lot of work was happening to identify, map, and calculate the movement of planets and stars. It's mostly motivated by the fact that some of the Islamic rituals require to understand the laws of movement quite well. So the movement of the sun, the movement of the moon, and your position and orientation in comparison to Mecca. That actually explains why many stars or even astronomy terms today have Arabic origins. In fact, some of the scientists of the time, like Al-Sijzi for example, started realizing that the rotation of the sky was not due to the sky itself moving, but to the Earth rotating around itself. Other ones like Al-Batruji, for example, start challenging the Ptolemaic system, saying that yes, it's quite efficient if you want to calculate the movement of planets, but it's not physical or real. His work and other criticisms from Ibn Rushd, At-Tusi, Ash-Shatir, Al-Urdi start triggering more debate among the scientists. More and more of them are not convinced of the Ptolemaic geocentric system anymore and start challenging its validity. And at that time, a very important man appears, Copernicus. Copernicus is the first man who publishes in 1543 a heliocentric model of the universe. In other words, the sun is now sitting at the center of everything instead of the Earth. Now, he makes this publication just 1 year before dying, and even then, the model is not widely accepted among the other scientists. We had to wait until 1610 before a new champion appears, Galileo. Galileo starts by discovering 4 of Jupiter's moons: Io, Callisto, Ganymede, and Europa. In other words, he discovers the first objects not orbiting the sun. But on top of that, he's also a very strong believer in the Copernican system. He does believe that things are orbiting the sun instead of the Earth. And this caused him a lot of trouble with the church at the time. In fact, the church was heavily supporting the Ptolemaic system, saying that the Earth was at the center of the universe because it was compatible with their understanding of the scriptures. And Galileo throwing that theory away was obviously very unpleasant to them, so he was forced to stay silent on the topic for almost a decade. His scriptures were banned, his work was forbidden from being shared, and he spent the rest of his life pretty much under house arrest until his death in 1642. But despite all that, he is considered today to be an absolute pillar of modern science. Anyway, back to space exploration. So around the late 1600s, approximately the same period, Cassini and Huygens continued discovering new objects in space, so some of Saturn's moons precisely. But it's also around that period that Isaac Newton appears, and his biggest contribution to the field of astronomy is the first reflecting telescope ever. In other words, a telescope that instead of using combinations of lenses to produce an image, uses for the first time a mirror to do so. Now, this is an absolute key step in improving the quality of the images we get from telescopes. In fact, all of the major telescopes you heard of today are probably reflecting telescopes, but at the time it took almost 100 years for this type of telescope to start becoming popular, simply because the quality of the mirrors they could produce at the time was absolutely terrible, and the images ended up being distorted and looking very ugly. Fast forward to 1781, Herschel is looking in his telescope one night and he sees a comet that looks a bit weird. It ends up being the first observation of Uranus ever. 20 years after that, Giuseppe Piazzi is also looking in his telescope and he sees a new planet that he calls Ceres, sitting somewhere between Mars and Jupiter. Today it's not really considered a planet, they call it a dwarf planet, in other words, an object that is too small to clear the entire path that it's orbiting. Add 45 years to that, and Galen Leverrier discovered Neptune for the first time in 1846, and in 1930, Tombaugh discovers Pluto. We have it, finally. The entire solar system has been identified, or at least the major objects in it. It took us 4,000 years between the first discoveries by the Babylonians and the discovery of Pluto to see the full horizon. So, is that enough to satisfy our desire for exploration? Of course not. Now, observing other planets is one thing, but going there is a completely different game. In fact, the hardest step is leaving Earth itself. People don't often realize how much harder it is to leave Earth compared to moving between the different planets. For example, Saturn V, or the Apollo rocket that went to the moon, consumed 2,500 tons of fuel to leave the Earth and go into low Earth orbit, but it only needed to consume 108 tons to move between the Earth and the moon. Now, at this step, we may know where the planets are, but we have absolutely no idea how to get there. And the first person credited with putting together the rocket equation to solve that is the British mathematician William Moore in 1813. And his work is mostly revolving around Newton's third law of motion, the concept of action and reaction. But the first person who is credited to take that rocket equation and apply it for the first time to space travel is a very important Russian man, Tsiolkovsky. Basically, Tsiolkovsky in 1903 develops for the first time the rocket equation that would allow us to travel to space. And a good example he uses to illustrate that concept is his famous experiment of the boat. Now imagine you're standing on a boat in the middle of the ocean, you can see the shore and you're trying to go there. On your boat, you have packs of stones. You will notice that if you take the stones and throw them in the opposite direction to the shore, as fast as you can, your boat will slowly start moving towards the shore. The faster you throw the rocks, the faster you will move towards the shore. Again, the concept of action and reaction. This concept is pretty much the same concept that every single rocket you ever heard of uses today. Tsiolkovsky also developed a space elevator model, but obviously that concept wasn't quite as successful. He was also the first person to calculate the Earth escape velocity. In other words, the speed you need if you want to leave Earth's gravity, which is 8 kilometers a second approximately. And finally, a very important piece of contribution he did was the concept of multi-stage rockets. In other words, different pieces with different engines and rockets functioning with liquid oxygen and liquid hydrogen together. Well, he had the concept, but he never built it. The first person to ever build that type of rocket was the American Robert Goddard in 1926, another giant of space history. Now, at the time, Goddard knew that oxygen and hydrogen was a very good and very efficient fuel combination, but liquid hydrogen was not very available in the market. He ended up having to develop his multi-stage rocket with oxygen and gasoline instead. And to test this absolutely historic creation for the first time, he went to his Aunt Effie's farm in Auburn with his wife Esther Goddard, who often helped documenting the experiments, with his crew chief Henry Sachs and his colleague Percy Roop. And the test was a huge success. The rocket lifted off by 12.5 meters for 2.5 seconds and ended up crashing in a nearby cabbage field. To document this huge moment in space history, his diary says the following: March 16. Went to Auburn with Sachs in AM. Esther and Mr. Roop came out at 1 p.m. Tried rocket at 2:30, it rose 41 feet and went 184 feet in 2.5 seconds, after the lower half of the nozzle burned off. Brought materials to lab. Exciting. Anyway, obviously this is a huge step in the development of rockets, but it's still an experiment. 18 years after that, however, Goddard's experiments became operational and fully functional for the first time. For another use, however. In fact, on the other side of the planet, another version of this technology was being developed by a soon-to-be American scientist, but not yet at this stage. Wernher von Braun was born in 1912 from a civil servant and conservative politician called Magnus von Braun. He's a pretty talented kid. He learns the cello, he learns the piano, even wants to become a composer at some point, but he develops an early interest in astronomy, especially after his mother offered him a telescope. At boarding school, he even finds a copy of the book By Rocket into Planetary Space by Hermann Oberth himself, one of the big names of space like Tsiolkovsky or Goddard. So he is by all means a space enthusiast, and he continues his studies in the space field until he reaches his PhD in 1934 from the University of Berlin. And it's not the type of PhD you imagine, with him just making some calculations and paperwork on his desk. In fact, by that time, his research group had already launched 2 A2 rockets, one flying to 2.2 kilometers and the other to 3.5 kilometers altitude, a huge achievement at the time. What you need to realize is that at that time Germany was under the Treaty of Versailles, which is a result of World War I. If you don't know what the Treaty of Versailles is, it's basically a set of very harsh constraints on the German army to prevent them from developing an offensive capacity. Basically, limitations and bans were imposed on the German army. They can't own a specific quantity of armored cars, tanks, ships, planes. But curiously, rocketry was not included in the list of weapons that they couldn't work with. In fact, it wasn't really considered to be a weapon at the time, which was a key factor in allowing von Braun to develop his career as a space scientist. Until he joined the Nazi Party in 1937. And he joined also the SS in 1940. I mean, you could see it coming, right? Funny enough, Germany was actually very interested in Goddard's work. In fact, German scientists had contacted Goddard directly before the war started to ask some technical questions about his research. In fact, Wernher von Braun used Goddard's work as a main source of inspiration and information for the development of the German rockets. And the results were really successful. Hitler had ordered the mass production of aggregate 4 rockets, in other words, the V2 rocket that you might have heard of. He had ordered them as a vengeance weapon, and around 1944, these rockets were already operational and flying over Allied territory. It is said that between 1944 and the end of the war, 3,000 V2 rockets were launched over Allied cities. By the way, Goddard realized that the design was heavily inspired from his work. One specific occurrence was quite interesting. In Sweden, a V2 rocket was launched, but it crashed, and the remains or the debris were collected and sent to the US in Annapolis for analysis. At that time, Goddard was working in that specific lab to do some research for the Navy, and it is said that upon seeing the components of the debris, he recognized some specific components that were his own invention. Now, let's not jump to conclusions. Yes, obviously it was heavily inspired from Goddard's work, but von Braun and his team did a lot of work in improving the design. In fact, the V2 is the first rocket to ever pass the von Karman line, which is the 100 kilometers of altitude line. Today, it's the definition of space that is mostly accepted. Also, a big difference compared to the Goddard design is that instead of using gasoline and liquid oxygen like Goddard did, von Braun used liquid oxygen but ethanol and water mixed together. Anyway, the results were so impressive that von Braun was nominated as a professor by Hitler himself. He was also decorated twice by the Führer, one of them being with the famous Iron Cross. Unfortunately for him, his career in Germany didn't really continue greatly. In fact, he was reported by an SS spy, a female dentist, while chatting with some of his colleagues a bit too openly, regretting that they weren't working on a spaceship more, and talking about the fact that the war was not going very well. This defeatist attitude earned them to be labeled as communist sympathizers and accusing them of sabotaging the V2 program. This was obviously enough for him to get arrested by the Gestapo in March 1944, but he only stayed inside 2 weeks, got released conditionally because he was considered too much of a crucial asset to stay in prison. So now he's out and he's able to continue his work and his research, but in 1945 things are starting to take a very different shift. Allied forces are considerably winning the war and they are invading the entirety of Germany. At that time, von Braun and his team surrender to the Americans, get captured by them, and after some interviewing, the US Counterintelligence Corps ends up finding 14 tons of hidden V2 documentation. Now, the documentation loot is absolutely massive, of course, but the Americans were really aware of who they had captured, and it didn't take long before von Braun had a contract with the US Army for the next few decades. He was so high on everyone's priority list that even before he got moved from the American-controlled area of Germany to the US itself, the Soviets tried to kidnap him, dressing as English soldiers and asking to come and see him, but the US soldiers ended up recognizing them and not allowing them to pass. Now, at this stage, you can probably guess that no one really cares about space exploration or space flight, right? Everyone is basically just focused on one thing: weapons. More powerful, more accurate, and further reach weapons. But to be fair, the V2 was used by the Americans for some scientific research in the late 40s. It is, for example, at that time that you started to see the first animals going on rockets and trying to reach space. Albert II, for example, who didn't survive the landing, unfortunately. In fact, von Braun was directly leading the development of the Redstone project at that time, the nuclear ballistic missile for the Americans in the 50s. Change a few things to that design and you get the Jupiter C rocket. Change the design a little bit again and you get the Juno 1 rocket, or the rocket used to send the West's first satellite ever, Explorer 1. Now, this is the moment where things are starting to shift once more. At first we were just struggling to see the full horizon and to get the full picture of the solar system. After that, a mix of genius, conflict and ambition allowed us to crack the rocket equation and to start reaching space. This allows us now to enter the third phase of space exploration. Space is now reachable. It's no longer a far distant dream. We know how to get there, but we realize there are many things we still don't understand. I mean, even about Earth's proximity first. Is it even dangerous to fly to space? Can we come back? How do we use this space presence to help us for our goals down here? Also, those planets that we seem to be targeting and we are dreaming of flying there, we don't know much about them. What should we expect? How do they work? Are they the same as us? Are they considerably different planets? And what's the best way to motivate spending more money on all these questions? Another war. Obviously, a cold one this time. Now, I'm not getting into the whole politics of the Cold War, obviously, this is not a political video anyway, but I really want you to realize how much things have accelerated during that period of time. I mean, we talked about 4,000 years to discover the full horizon, and we talked about almost a century to crack the rocket equation, but in only a few decades, we have managed to considerably expand our presence in the solar system. And of course, listing every single space mission that happened between the 50s and now would not be very useful, but let me try and at least focus on the most important missions from a space exploration perspective. So the real start of this phase is in 1957 with Sputnik 1, the first ever man-made satellite to be able to orbit the Earth. It was sent by the Soviets, and it was basically the first time where we were not only going to space, but for the first time we're now able to stay there. Another interesting milestone is Vanguard 1 in 1958, an American satellite this time. It was the first time we used solar panels on the satellite to generate electricity, a practice that is now considered to be the standard of the industry. Again, very quickly after that in 1959, the Soviets strike again, and they try to reach the moon twice with the missions Luna 1 and Luna 2. Luna 1 ends up completely missing the moon. Basically, the signal to cut the engine was supposed to be sent from the ground using radio signals, but the signal arrives too late and the rocket completely misses its target. Luna 2, however, does not do the same mistake, and it ends up crashing on the moon, making it the first man-made object to ever reach a celestial body apart from the Earth. Also, another more famous blow from the Soviets in 1961 is the flight of Yuri Gagarin, the first man to ever orbit the planet and come back alive. Now, all of these missions were targeting either the Earth itself, its close orbit, or the moon, so everything was pretty close to us. But for the first time in 1962, the Americans sent the Mariner 2 mission, and it's the first successful mission to go to another planet, Venus, and send back data from it. Again, in 1965, the Mariner 4 mission manages to send us back some pictures from Mars. And at this point, it really looks like the Americans are completely dominating, but in 1966, the Soviets catch back and manage to, for the first time, soft land a spacecraft on the moon in the Luna 9 mission. Same year, the Americans are definitely still in the competition and they send the Lunar Orbiter 1 mission to map the moon for the first time. But only 2 years after that, the Soviets managed to send plants and animals to the moon for the first time. They even managed to recover the spacecraft with the Zond 5 mission. And it looks like a big success. I mean, obviously, sending plants and animals and even managing to recover the spacecraft is a very difficult thing to do. But only 3 months after that, the Americans sent Saturn V with a human being inside in mission Apollo 8. Now, this is a very, very big success. Saturn V is the biggest rocket ever made, and by the way, remember Professor Von Braun? Well, he was the chief architect of the Saturn V rocket development. And it definitely paid off. I mean, the Apollo program was pretty much the peak of the American victory in the space race. And of course the space race continued after that, but the dynamics started changing a little bit. I mean, NASA had achieved enormous success with the Apollo program. There were even proposals about building space stations around the Earth and around the Moon, but on one side, Nixon was realizing the declining political support in Congress for even more money on huge and fancy space programs. At the same time, the relationship between the US and the Soviets and China was more going towards easing tensions than even more competition. Now, this didn't prevent other exploration missions from happening, like Pioneer 10, for example, in 1972, with an exploration of the asteroid belt and Jupiter. By the way, Jupiter is very far away. There was also the Mariner 10 mission in 1974 that went to Mercury and Venus. Even the Soviets were still in the run in 1971 with the Mars 3 mission, for example, where they sent signals from the surface of Mars for the first time in history. But the atmosphere was definitely different, and more cooperative projects started to appear, like the famous Apollo-Soyuz test program in 1975, for example, a big mission that was organized by both the Soviets and the Americans together to try and dock both of their modules together and have both crews meet each other and shake hands. By the way, this picture of the two mission commanders shaking hands became a big symbol of a new, calmer phase of the space race. It's also around that same period of time that an absolute pillar of space exploration was launched, the Voyager missions. So in most previous missions, we were often targeting something relatively close to us, so the Moon, some of our nearby planets. But the target for the Voyager missions is much, much further away. Both of the probes are simply trying to get out of the solar system completely. It allowed us to take much closer pictures of Saturn, Jupiter, and their moons. Actually, most of the pictures that you saw from Jupiter or Saturn today are coming from the Voyager missions. And in 1990, Voyager 1 took the famous family portrait picture with 6 planets of the solar system, including the pale blue dot image of the Earth. Now, starting from the 80s, something else very important started accelerating a lot in the space industry: the arrival of new players in the space race. Brazil, Canada, China, South Korea, the Netherlands, Italy, even some of the countries that had a national space program dating from the 60s, like France and India, for example, considerably accelerated their activity during that period. Some even created close cooperations with NASA, like ESA, for example, on the Hubble Space Telescope project in 1990. Actually, the biggest space cooperation of all, the ISS, was in the 90s between Canada, Europe, Japan, Russia, and the US. And unsurprisingly, the number of scouting missions across the solar system also accelerated with this. Cassini-Huygens, for example, was launched in 1997 between NASA, ESA, and the Italian Space Agency, and it was aiming to visit Venus, Jupiter, Saturn, and even land on Titan, one of Saturn's moons. And here we are in the early 2000s, our closest neighbors, the Moon and Mars, started seeing visits from more and more players of the space race: Indian spacecrafts, Japanese, Chinese, and of course American missions. The mission Chang'e 6, for example, was particularly impressive. I mean, in 2024, it returned samples back to Earth from the Moon. Mars also started receiving more visitors from probes that were not only able to take pictures, but also capable of taking samples, analyzing them on site, and even preparing them for delivery back to Earth at some point. I mean, NASA even flied a small helicopter on Mars in the Ingenuity mission. And there is still so much more coming. Because this is what we do, right? Us humans. We see the horizon, we plan for it, and we explore.